Okay, so today we're going to talk about, this is page 77 in your textbook. We're going to talk about limits on populations because we dealt with this in the Pike and Perch lab. Do you remember, Mark? That conversation is not over. Do you remember in the Pike versus Perch lab what the carrying capacity of the lake was? The number. What was it, Brian? 150, that is correct. And what does carrying capacity refer to? Do you think? Yeah, the total number of people that can, the organisms that can live there. So after this, you're going to know the term carrying capacity. You're going to know what density independent and density dependent factors are as well. Let's watch a video. Give me an example where weather is a limiting factor in human population growth. Braden? I'll restate the question for Braden. Give me an example where weather is a limiting factor for human population. What do you say, Braden? For humans, Jake, yeah. What do you say, Jake? Floods? Those are, well, explain tornadoes. What do you mean? Eh? Wasps? What did you say? What do you say, Jake? Give me an example of where weather plays a limiting role for human population. I guess what I'm saying is, okay, let's step back a little bit here. Where are there less humans? Give me an example of a place where there's not too many humans. North Pole. Are those examples? Like, are there less people that live in the Arctic? How come? It's cold! Less food. Exactly. That's an example. Brody was doing a pretty good job of impersonating your voice there. Okay. On your sheet, you should answer. Oh, jeez. I think I've given it away. I do this all the time. Why is the world not overrun with mice? Field mice may have litters with 6 or more pups, it says in the book. They can reproduce every 6 weeks. It takes only 6 weeks for a mouse to become sexually mature. In 6 months, a population of 20 mice could become a population of 5,120. And I know that from experience. Can I tell you a side story?
Sure. Waste some time.
Okay, so the question is, how come the world is not overpopulated with mice? How come? There are some limiting factors. Mice have been around for millions of years, so why is it that when you look out the window, you see grass and trees and birds and squirrels and not a vast carpet of millions and millions of mice? Well, it's because why? There's a limit. There's a limit to how many mice and other organisms can exist on Earth. First of all, there are animals that eat mice, right? And as we discovered in the Pike and Perch lab, when the number of prey, the perch, or the number of mice goes up, what else goes up? Braden, I need you to listen. If the number of mice goes up, what kind of animals eat mice? Cats?
People.
Maybe snakes, maybe owls, hawks. When the number of mice goes up, those things go up in population because there's more food. What happens to the number of mice? Goes down. So there's a limit. Okay. One of the limits, one of the reasons why we're not overrun with mice is what we call biotic potential. And I think you have to fill in a couple blanks there, right? Biotic potential. Mice reproduce at a much faster rate than other animals. For example, bears take two years or more to become adult and able to have offspring. Mice, 6 weeks. Okay, so that is a biotic potential. There's going to be way more mice than there are bears. How come? Bears don't reproduce very fast. So an example of biotic potential is the reproduction rate. That's an example of biotic potential. Birth potential. It's on page 77 there. How much do you guys have to fill in there? Can I see? I never know. Here, I don't know. A couple words. Okay, here's the clicker question. What are you doing?
Take one laptop.
I think you're wrong. Jake doesn't want a laptop.
Oh, well then.
I'll be happy to do that for you. I'll just put it over here. We'll figure it out. Sure? It won't be a problem. Just put it over there. I'm offering to do it for you. Did you guys answer the question?
That's the question?
That's the question.
Oh, you mean biologic?
I was going to start yet? Yes, I did. I did. By the way, there are more than one answer. There's more than one answer. Biotic potential is regulated by what factors? And you'll find the answer on page 77.
It's so high in screen.
Really?
It's the thing in school. That was my story.
Jake, have you got a sheet? You don't have a sheet now. Okay, well, you need 77. Biotic potential is regulated by what factors? But birth potential, capacity survival, food supply, procreation, water supply, length of reproductive life, lifespan, organism size. Those all sound real good, don't they? You have to put more than one. To get it right, you have to put more than one. How many are there that are right, Reese? Do you know?
5, 4, 5.
Brody says 4.
6. Oh, I got it 5.
Did you press enter, Brody? Yeah. Yeah? Oh, Jake's getting in late here. Got an answer, Jake? Should I wait for you?
Yeah.
Awesome. The answers are A, B, D, and F. A, B, D, and F. Those are the 4 factors that regulate biotic potential. Okay? What does the word biotic mean? Has to do with life, right? Lifespan, the length that you live, isn't really something that's living, right? Birth potential, you're talking about how many babies are born. Capacity for survival, you're talking about whether things are dying or not, okay? Kind of confusing a little bit. Okay, so what are those 4 things? I think you need to fill them in, right? On the next page there, yes. So they are birth potential, which is the maximum number of offspring per birth. For humans, it's probably 2 or 3. Possible, I suppose. Dogs have litters up to what, about 7 or 8, maybe 10? 10 would be really a lot. Cats? I don't know much about cats.
7.
Yeah, about the same as dogs? Think about robins, birds that you might see in the spring. Maybe 2 or 3 birds, right? So, maximum number of offspring per birth is the birth potential. Dion, are you getting this down? Yeah? Right there, my friend. Capacity for survival, the number of offspring that actually reach reproductive age. Do they live long enough to become a mother or a father? Procreation, the number of times a species reproduces each year. In mice, it could be many times. Right? Bears take up to 2 years. The length of reproductive life, the age of sexual maturity and number of years that an organism can reproduce. All of those things are factors in limiting how big the population is. What do you think the most populous species on Earth is?
Beetles.
Animal. Is that right? I don't know. Do you know that for sure? Oh. It just sounded like you were confident. Anyone? What do you think? What's the most populous species on Earth?
Dog.
Dogs? Why don't you take 30 seconds and Google that up right now? I want to know. No, Google it up. Don't just guess. Most populous species. You got 30 seconds to Google while I go do attendance. What did we find out? This is a collection of lists by... Where's the list? Oh. Chinese alligator. List of organisms.
Most populated.
The number of described species has been estimated at that. Oh, is this what you're saying right here? 310 million. Yeah, but there's more than that in humans. I don't think that's right. I want this one here. Along with humans, who else in the 7 billion club? This is the one I want. Is that the one you went on? Best guesses. Fish. Blah, blah, blah.
What was the third one?
Yeah? This one here? Botanica? Can we trust them, do you think? They're a pretty reliable source. Well, Google just gathers information, Jake. It doesn't produce the information.
It's actually a search engine.
Yeah, exactly. So where am I looking here, Ron?
Click the arrow.
Click the arrow. Okay.
That's the most, yeah.
Ant seems like a pretty good answer, doesn't it? I mean, like even in your yard, there'd be like a couple thousand ants probably.
Yeah, apparently it's bacteria.
Yeah? Is that what Siri told you?
No, that's what Yahoo. Yahoo.
Yahoo's a search engine.
Yeah, well, it says
Ants are the most oh, that's number 7. Most numerous insect.
Oh, one.
Okay, well, let's go to 1. Go to 1. Doesn't want to go.
Click the arrow.
Click the arrow. Mammal. Humans are the so this is just categorized by types. Okay. All right. Okay. You have a chart to fill in. This chart is on page 78, I believe.
Make the Walking Dead.
We're going to talk about The Walking Dead right away. So, there are abiotic and biotic factors. What does the word abiotic mean? Non-living. Biotic means having to do with living. So, abiotic factors that cause a population to increase. Things like favorable light. Enough light for plants to produce food. Favorable temperature. Think about the Arctic desert. Favorable chemical environment. Those are abiotic factors that cause a population to increase. What would be some factors that cause a population to decrease? Well, too much or too little light. Too cold or too warm. Think about Goldilocks. Unfavorable chemical environment like pollution. Yes, Brad, you have a question? Oh, you have an answer? Okay, so what are some biotic factors that limit populations? Things like, is there enough food? Is there a low number of predators? Are there few diseases? There you go, Brad. And can they compete for resources? Factors that cause a population to decrease. Insufficient food, like when the perch population went down. Lots of predators. Lots of disease. Inability to compete for resources. Basically the opposite, right? Say again?
Why is this Walking Dead is gonna be like one of the Georgia and
So what's the deal with The Walking Dead? Why am I bringing that up?
Because it's the coolest show ever.
Okay. Well, what does that have to do with this? Let's just go through this list.
In basic things.
How many people are on Earth in The Walking Dead? Not 7 billion. We don't know.
Around million zombies.
Yeah, we don't know, but we know that the human population is significantly lower. Well, what was one factor that caused the population of humans to decrease? Insufficient food. No more people, no more farmers, no more ranchers. There is a food shortage. It spoils. Lots of predators. Zombies. Fair enough. Lots of diseases. So there's not just zombies, but there's also lots of other diseases that they don't have doctors, nurses, and hospitals to help with. An inability to compete for resources. Some people might die because they're unable to hunt. They're unable to fight off zombies. Walking Dead is a really good example of that. All right, let's talk about carrying capacity. Now, you've already been introduced to this when we did the Pike and Perch lab, the Pike and Perch simulation, Mark, right? Populations tend towards stability. That's always true. They tend to sort of try to level off. They're usually rather unsuccessful. Okay? This graph shows carrying capacity. The carrying capacity is the maximum number of individuals of a species, got an extra A in there, that can be supported indefinitely by an ecosystem. In our example, the pike and perch, the number was 150 perch in the lake. That's as much food as there is. Okay, that's called the carrying capacity, right? Do you like me? 51%, thanks. Did you know that The Walking Dead is a very good example of biotic factors that cause the population to decrease?
So is Ebola. High five.
Thanks for scaring my class, Mr.
Well, we're talking about viruses, so.
Yeah? Like, give me 3 minutes now. Okay. So, carrying capacity, we've done that. If populations go over the carrying capacity, often some will die out due to the lack of food, water, and other resources. So that's what this graph shows right here. Okay? If this is the carrying capacity here, and you've got an overshoot like that, what happens to food? If you go over the maximum allowed, they quickly run out of food. Everyone suffers. And what happens? It drops. Exactly. Okay, so you should know that. I may ask you, what will happen to a population when it goes over its carrying capacity? Your answer would be, the population does what? The population decreases. That would be your answer, right? I got one more slide left, Mark. Okay, last one. This is probably the most difficult concept of the day. So I know you're sort of wearing out a little bit, but let's just refocus for about 3 more minutes. Density dependent. First of all, what does density mean? If we talk about population density, I'll give you an example. How does the population density of Winnipeg compare to the population density of the Parkland? Which one would have a greater population density? Why Winnipeg? It's not just about more people. More people, smaller area, right? Density, population density. So if there's like lots of people, or even the same number of people all close together, as compared to far apart. That's what population density means. So population or density independent. What does the word independent mean? Tiana, what does the word independent mean? Yeah, what does that mean, non-dependent? Briar, what does independent mean?
You can do it yourself.
You can do it yourself, right? So density independent means that there are factors that don't depend on density. Do not depend. So there are factors that affect all the population regardless of how many there are. And good examples are fire or flood. Almost. I'm just about done, Mark. Hang on. Okay? If there's a fire, it doesn't matter the population density, everybody dies. If there's a flood, everyone's got a problem. There's no relationship between that and the population density. The reverse of that is density dependent. Factors that affect the population because of how many there are. Things like food supply, right? If there's not that many people, food supply is not that big of a deal. There are a lot of people, it is a big deal. Water quality, disease, because diseases spread when people are close together. Okay, so independent means not dependent on density, population. These ones are dependent. Okay. There's two short questions there. On page 80, I'm also going to take this last few minutes here to call people out about their projects. Some people are all done. They're good to go. I'm giving you your folder back. We're done. Other people I still need to see you about. Okay? So you've got a few minutes for that. If you could just circulate and help them with those two questions on page 80. And I'm going to be calling people up. Mark, you can go. Dion, you can go.